Hello, I am Pankaj Sharma from Brainleague Learning. In this video, we will build an intuitive picture of the TCP/IP model, the four-layer protocol stack that lets computers talk over the internet. The model has four layers, from bottom to top: link, internet, transport, and application. We will place a client on the left, the internet in the middle, and a server on the right. First, let's draw both stacks and the internet cloud between them. Layer 1 is the link layer, also called the network interface layer. It deals with how bits move over a local network like Wi-Fi or Ethernet. It breaks data into frames and uses hardware addresses called MAC addresses so local devices and switches know where to forward them. Let's highlight the link boxes. Layer 2 is the internet layer. Its job is to move packets across different networks. The main protocol is IP, Internet Protocol. It adds IP addresses to packets like street addresses and routers forward based on those addresses. Let's highlight the internet boxes and show an example address pair. Layer 3 is the transport layer. It ensures host-to-host delivery. There are two main choices. TCP makes a virtual connection and ensures all parts arrive in order without errors. UDP sends without a connection, faster but less reliable, good for games and video calls. We'll highlight the transport boxes and show both options side by side. Layer 4 is the application layer. This is where user programs live, the browser, email client, or a game. It defines the rules those programs use to talk, like HTTP for the web, DNS for names, and SMTP for email. Let's highlight the application boxes and add some protocol examples. Now, let's walk through what happens when you visit a website. Step 1. Your browser at the application layer creates an HTTP request, like get/. We'll place that request on the client application box. Step 2. The transport layer, TCP, breaks data into segments and numbers them. We'll wrap the request with a TCP header. Step 3. The internet layer, IP, adds source and destination IP addresses. We'll add an IP header with addresses. Step 4. The link layer frames it with local MAC addresses and sends it across the local link to your router and onward. We'll add an Ethernet frame and move the data through the internet cloud to the server. Step 5. On the server side, each layer removes its own header, delivering the HTTP request up to the server's application. We'll show it arriving at the server application box. To recap, link layer frames data on local networks. Internet layer routes across networks using IP addresses. Transport layer delivers host-to-host using TCP or UDP. Application layer defines app rules like HTTP and DNS. A key idea is layering. Each layer only talks to the one above and the one below. This separation makes systems simpler to design and troubleshoot. Great work following along. Now, when you click a link in a browser, you can picture the request moving down through application, transport, internet, and link, hopping across the internet, then climbing up the stack on the server. See you next time.